Here we will take a look at a custom XC series controller. This is an XC9 and an XC6 with RGB buttons being set up for one of our customers who ordered this in a blue color. That's great. And the really awesome thing about it is how we are using shift states and registers and all that stuff. That's mainly on this section. So I will now go zoom in on this part. Although this is a great and awesome too, this is where all the action is that is related to system actions and will teach us a lot about how to use states and shift registers, in particular states in this case, and also sections and module virtual components. Zooming in on this section, we see we have 5 buttons here, which will basically select different states for this part of the controller. So as I press this one, it will now change something. And what was it changed? Well, first of all, we are connected to an ATEM switch, and that's an ATEM Television Studio HD. So you can see from the software in the background that I'm changing sources on preview and program on this one. Actually, I even have ability to work on ME2, which is the case now. But since we don't have any ME2, they are just turned off. I enable ME1 again. I have a shift key as well on the right side, the XC9, and the shift key will give me access to sources from 9 through 16, which are not available at the moment since it's only a Television Studio HD. But it won't spoil our presentation though. And the media player over here, index 1 through 8, index 9 through 16, as I enabled the shift key on the other side of the controller. And whenever I press here, this functionality is maintained, while this one will now work with media player 2. When I go here, we have macro playback. When I go here, we have access to a video router. So as I press these buttons, I can select an output and then I can execute routes. If I bring up the software for the video hub, you see I select output number 1, I route source number 1 to that one, I select output number 2, I could even select output number 3 by grouping them together. So now 2, 3, and 4, and I can route input number 6 to that one, all at the same time. Labels are pulled over from the video hub nicely as well, so you can always see where you're pushing stuff to. And then finally on this button we have auxiliary 1 and auxiliary 2, and what you also see is that we have a lot of colors, color schemes going on that makes it more user-friendly or easy to identify. For instance, you can say, okay, hey, blue, that's the video router, and well, spring green, that's auxiliary 1, and rose is auxiliary 2, and regular white with red and green tally is the typical mixing of program preview. So forth. Media player is purple or it's pink. Now let's take a look at how this is configured, because it's all Unisketch configuration. Yay! And we go to the interface here. This is the configuration we see right here. And one of the main purposes of this video would be to demonstrate what module and sections are. And these are virtual components. Let's see if I can zoom in a little bit on this graphic. So we call them virtual components because in itself, they do not send any actions. They are not button presses, they are not pulses, they are not analog components. They are simply there to evaluate or set up some functionality. So when I click this, you will see, and now I need to zoom out again, you'll see that for the module, okay, nothing has been set. Well, that's not entirely true. This module you see here belongs to 27. That's hardware interface component for the module. This module, I am pretty sure. While this is the module we're looking for, the one sitting on the other side. We could also say XC6 module to make it easy for ourselves. Save the settings. And now it should be absolutely clear from the label that this is what we are talking about. That label is just to help ourselves. Now, for the module section 1, you see they contain some actions which are essentially configuration. So we already touched on the local state registers. No, actually we touched on the local shift registers, which were ways to keep up to 5 different shift registers running at the same time separately, but you can do the same for states even. So you see how I have divided the controller into 5 states, but I call them normal, state 1, state 2, state 3, and state 4, instead of giving them names like ME, this and that, macros, video hub, and what was the last thing I had? Oh, that was, let's see. Okay, so that was auxiliary buses. I could give them names like that, but what I decided was to say for the XC6 module, I want to use a shift register P, which will affect how shift states are evaluated for this whole module. For the whole module, shift register P is going to determine what state this module is in. So what it means is that I could have a different state for this module, or if I added more modules, I could have different states for those, which means it's easy to group functionality within this part, this controller, and I could still also expand that to the other modules in the chain. I can even go down on section level, because where the XC6 module virtual component configures for the whole module, this configures for this particular section. This is what the purple areas indicate. That's the section that are governed by this virtual component. The same for this and for this. Now, let's take a look at the configurations we actually had. Okay. So, if I press this button, let's take a look at what happens on this one. And we go down here. I need to zoom out again. Yes, okay. And in the normal, no, wait. Actually, what we need to do is to take a look at these buttons. So M1, the first one that I use for setting states, what we see is that it sets state 0 for register P, and then it has the local color mint. Aha. So M2 is just below. That's the next button to the right of this one. State 1 for register P. And guess what? The next would be state 2, the next state 3, the next state 4. Okay, that makes sense. In other words, the buttons I have here, 1, 2, 3, 4, and 5, those buttons up here, they are mint colored, and they set state 0, 1, 2, 3, and 4. Great. So it absolutely corresponds with what we expect, that these 5 columns would be the states set by those buttons. And we also saw that the XC6 module hardware component sets local state register P to be the one that defines how this whole system works. What we can see is this section number 3 is different from this section. So I wonder if any particular configuration has been set up for that section. And let's go to the top first, which makes it easy for us to click down to this one. And actually, it turns out that this is the case. You can see for section 3, we have defined a local color to be purple. We see purple. And if I click here, we see pink. And that's the local color for state 1. So that makes sense. Okay, so what about states and shift levels? Okay, so if we look at any of these buttons we have here, again, let's go to the top and use this to click down here. Then we see for this button, we have selected ATEM program source from memory A. Oh, memory A instead of ME1 and 2. That's the register I set by the ME1, 2 button on the XC9 I talked about. And then we have 9 and 1 and 9 as the input sources. We have OR as the divider between those two actions. All as we expected. Also notice how we do not fill anything in for state 1. So this is the reason why when I push here to go to state number 1 instead of state 0, these are still displaying the same functions because they are just falling back to the normal state. If I use states further out here, I would have to replicate this behavior, but right now it's kind of nice and easy because it just falls back to this one. Okay, so what else do we want to take a look at? Well, so we now saw how the pink colors came up, and if we go here, we have the macro playback. That's probably kind of easy as well. maybe we should take a look at these because they are turned off. And we saw in a previous video how if you, now as I click this, it's necessary that you insert a no action, action, if you do not want in a particular state to fall back to the default. So that's what I did. Then let's go to the next one. We see video routing here, and that's what we have in state number 3. Again, this is kind of standard. I could just maybe quickly talk about how this is generally configured, but for the top row, we select we perform the route. This would be selection of the sources. So if I click this, we see here we simply route an input to an output. That's the action. It's taken from the destination is memory group AA, and this is input 1 or input 13. Oh, this means because I'm connected to a 16 input video hub, so this is just a small comment on how this has been implemented. You can see it's actually set up to go all the way to 2024, but since we have only input 16, these are disabled. There are simply no sources for them. But that's a detail about video hubs. What you do see is that we use blue color in this case. So I wonder if state 3 has something with blue color going on. And again, since this video as something new introduces sections, let's take a look at the sections in case of state 3. And we see in state 3, yes, we're using a local color that's blue. And we can now go to the top and see if that's the case for section 2 as well. And it turns out, oh, it is tied to hardware component 29. What does that mean? And the same over here. That's interesting. Let's just, before we explore that, see what happens in section 3. In section 3, oh, that's also tied to hardware component 29, but not in state 4. So I wonder if I click here, this section is turned off in the in state 4, while in this one it's the same. And tying something to a different hardware component is basically a reference back to a different number up here. So this is hardware component 73, and this says that in state 3 we will insert the hardware component or behavior of 29. Okay, now I may be mumbling a little bit, so let's find 29. Well, I would guess 29 is this guy, and that turns out to be true. It is 29. So what it means is by referring back to this one, we are picking up the local color that is set here. So I just need one place, this place, to change blue to something else. And since my 2 other sections are referring back to that one, section 2 and section 3, we had we tied it back to section 1. This change in section 1 will channel through to section 2 and 3, which is kind of awesome in terms of simplifying things, as long as you can keep track of your references, of course. And actually, that's something that you will see on this controller in many other cases, because the displays and the buttons are independent, but yet all the display tiles are linked to buttons in a fashion that's actually fixed. But the fixedness of this is something that's simply defined by, if I click this display, you'll see it's simply defined again by tying the display to a hardware component. So in this case, it's 39. So display 1 is linked to H1 button 39. Display 2 is linked to hardware component 40, which is the next button, H2, right here. So there you see how all the displays, all 24 of them, are linked to the 24 buttons by using the tie to hardware component. And that's a very typical use of tie to hardware component you see right there. I think that kind of concludes it. I have nothing else to share. There are definitely details in how this configuration has been achieved, which would be worth mentioning. But for now, this is mainly it. Well, yeah, again, we have colors going on here. And since, and maybe we should take a look at that just quickly. because what we have seen so far is that we set color for a whole section, in this case blue, green over here and purple here. But if we go to this one, what about this? Here now colors are the same, not the same in a whole section. Actually, we have spring green here, we have rose here. So how did we achieve that? And since, and that's a consequence of how the controller has been divided into sections. So this section will include all these 13 buttons and 8 displays. But these buttons are independently set to green. And that's clear if we go to that action. We can see that in state 4, it's set up to do something with auxiliary on an ATEM switcher. But for each action, we have to include a local color to make sure that it is spring green. And that's the consequence of, I don't know if it's inflexibility, but this is just how it works. Whenever something is divided into a section cannot go across in a different direction. So it's a consequence of that, but it's still possible. And if we go to this one, you'll see, well, that was a point. So we see this button did not have a color action. You see there's no color action for this guy, but it turns out that there's one for this one. So what could that mean? Actually, it means that the color that defines this one on the local level is overruling a color set on a section level. So let's just go check. And we see that in state 4, the local color is set to rose, and that is traveling down through the section and hitting these buttons, except that we are overruling that color information for this one. Neat. And that kind of gives me the urge to take a look at the module again, because maybe we could even see here that something like a color had been set for the whole XC6. And you would actually say that in state 3, where we have blue color across the whole controller, we could actually expect to set a local color on the module level, and that would be inherited down through the system.